So for today's homework solutions, our first question, a rock is thrown off a cliff according to the equation y equals negative 5x squared plus 15x plus 30, where y represents the height of a rock in meters and x represents the time in seconds. So we're asked to use the values from -2 to 5, so we'll simply plug in these values into this equation to give us a series of y values, and then we can fill in our xy coordinates. Now, filling in or plotting each of these coordinates, we'll get a parabola that looks something like this. And here's our y-axis, the height in meters, and here's our x-axis, the time in seconds. We see the parabola faces down because we have a negative sign in front of the x squared coefficient. Now we're asked for a series of solutions to various questions relating to this graph. The first one is, how high is the rock after 1 second? Well, we simply move along the x-axis to the 1 second mark, and we can see that it crosses the graph at the 40 meter mark. And then we're asked, how high is the cliff? Well, we have to assume that at the 0 second mark, the rock is being thrown from the cliff. So whatever our rock height is at 0 seconds is going to be the height of the cliff. Number 3 asks, how long does it take for the rock to hit the ground? Well, we simply follow the x-axis until we see that the graph crosses this point right here, and y has a value of 0. So if y is our height and y equals 0, it crosses right here about the 4.5 second mark. Now we're asked, what is the maximum height reached by the rock? Well, again, we simply travel up the y-axis until we find what the graph's highest point is right here at the vertex. We can see that it occurs somewhere around the 41 meter mark. Question 5 asks, when does the rock reach its maximum height? Well, here's the maximum height right here, and if we follow an imaginary line or down here to the axis of symmetry, we'll see that this occurs at approximately 1.5 seconds. And our last question, number 6, is when is the rock at 20 meters? Well, we find the 20 meter mark on the y-axis, and we see that it crosses right here at about the 3.5 second mark. Our next question, number 2, a model rocket is launched from the top of a building. The equation is y equals negative 4x squared plus 20x plus 10. Y describes the height of the rocket above the ground in meters, and x describes the time in seconds. So we're asked to use x values from -1 to 6. So once again, we'll plug these values into our equation and get a series of answers. So our first coordinate here is -1, -14, 0, 10, and so on. When we plug these coordinates in, we'll get a graph that looks something like this. Notice that we have a negative sign in front of the x squared coefficient. So once again, we get this shape, this sad face shape opening up downwards. And these questions relating to the graph, how high is the building? Well, once again, at 0 seconds, we have to assume that the height of the building is the same as the height of the rocket, because that's where it's being launched from. So the height here is 10 meters at 0 seconds. So we'll fill that in as the height of the building. Now we're asked, how high is the rocket after 4 seconds? Well, we'll travel along to the 4-second mark, and we'll see that that crosses at about the 26-meter mark. How long does it take the rocket to crash? Well, we assume that it's crashing on the ground, so we'll come down here to where y equals 0, and that happens at about the 5.46 second mark. What is the maximum height reached by the rocket? Let's go up to our vertex here and see the highest point. And we can see that 35 meters is the y value. And when does the rocket reach its maximum height? Well, this x value right here tells us what our time is. So it's hitting the 35-meter mark, the maximum height, at about 2.5 seconds. And then we're asked, when is the rocket at 20 meters? Well, the rocket is at 20 meters at 2 points. It happens at the 0.5 second mark as it's going upwards, and then after it reaches its highest point and starts to come down, it reaches 20 meters again at the 4.5 second mark. So we have to answer this with 2 coordinates.